Hello everyone. I hope all of you are doing well. I am Shivam Aggarwal, PhD scholar in Material Science and Engineering Department, IIT Kanpur. This is my YouTube channel, Materials Physica, and this is my second video in this channel, which is about materials properties. Mainly, today we will discuss about the crystal structure, and in this session we will solve problems which are relevant to the Bragg's law. Now, let us start. A narrow beam of the X-ray with wavelength 1.5 angstrom reflected from a ionic crystal with an FCC lattice structure, and the density of the structure is a 3.32 gram per centimeter cube. The molecular weight is 108 AMU, atomic mass unit. The lattice constant is, and we have to calculate the sign of the angle corresponding to 111 reflection. So we have to calculate the lattice constant, and we have the wavelength and the density and the molecular weight of crystal, and we also know that it is a FCC lattice structure. So we know the density of a crystal rho is given by N effective multiplied by molecular weight over volume of unit cell, and for cubic it would be A cube into number of Avogadro number and A. So here we know value of M is 108 AMU, and Na is, as you know, Avogadro number is 6.022 into 10 power 23 atoms or moles per, sorry, atoms or molecules per mole. And A is we have to calculate, density is not, and N effective for FCC crystal structure is there is a 8 corner, and effective atoms per corner is 1/8. So 1/8 into 8 plus there should be an atom at all the faces of the lattice. So there are the 6 phases, and each phases have the effective atom is half. So total effective would be 1, and plus 3, 4. So A cube would be N effective into M over rho into Na, and value of A is 4, is 108, is 3.38 into, and value of Na is 6.022 33 A cube, and A cube 21.6 into 10 to the power minus 23 centimeter cube, or we solve for the value of A is 6.0 into 10 or minus 8 centimeter, or value of A would be 6.0 angstrom. So the first part of the question is solved. The lattice constant is 6.0 angstrom. Now the next part, the sign of the angle corresponding to 111 reflection. So by Bragg's law, 2D sine theta is equal to n lambda, but here n is not given, so mainly we will take n is equal to 1. So 2D sine theta is equal to lambda, and we have to calculate the sine theta for this question. And D HKL is for a cubic crystal is given by A over under root H square plus k square plus L square, and we have in question D111. So it would be value of A is 6, and 1 square plus 1 square plus 1 square become 6 over root 3. Now, when we put all these values in the formula, we will get 2 into 6 over root 3 into sine theta is equal to lambda is the question is given 1.5 angstrom. So sine theta is equal to 1.5 root 3 2 into 6 or root 3 over 8. So this is the answer for the second part of the question, which is we have to calculate the sine of the angle corresponding to 111 reflection. So this is root 3 over 8. Now move on to the next question. A powder camera of the radius 55 mm is used to obtain the diffraction pattern of the gold. Having the lattice parameter is the 4.8 angstrom. For FCC structure, the monochromic molybdenum K alpha radiation of wavelength 0.68 angstrom. So we have to calculate the first 4 Bragg's angle at which deflection occur. So for this type of question, by Bragg's law, let us see. Two D HKL sin theta is equal to lambda, and we have to calculate the value of theta first for theta, and we know lambda and A, and D HKL is given A over under root H square plus K square plus L square for a cubic crystal. So here we know the value of A, but I don't know about the H, K and L. And in this question, it is asked first 4 Bragg's angle. So for first 4 Bragg's angle, we know there are a selection rule for value of HKL for FCC type of crystal. All HK and L should be even, all, or all should be all. Then reflection will occur, otherwise reflection will not be occurred in FCC structure. So let us make combination according to that condition. All should be odd and all should be even. And for first, there should be value of H square plus K square plus L square in the ascending order. Now let us check. First, all are odd, 111, and the value of H square plus K square plus L square for this is 1 square plus 1 square plus 1 square is 3. And for now next 2 0 0 for this would be 4, and next would be 2 2 0, all are even, and next would be 1 1 3, and many more. And if we check H square plus K square plus L square for this is for this 3, for this 4, for this 8, and for this 11. So this is also in ascending order. So this reflection is the first reflection, is the First for Bragg reflection. Now let us calculate the value of theta. So by Bragg's law, sin theta equal to lambda under root h square plus k square plus l square over a. Now for 111 reflection, sin theta 1 is equal to value of lambda is 0.68 and value of under root h square plus k square plus l square is 1 square plus 1 square plus 1 square over value of a is 4.8 angstrom. So 0.68 23 over 4.8. When we solve it, we will get 0.29. This is the value of sin theta 1. And the value of theta 1 is equal to sin inverse 0.29, and that would be 16.95 angstrom. And similarly for and next reflection is the 200. Sin theta 2 0.68 and value of h square plus k square is 4 and it is 4.8 and sin theta 2 is equal to 0.3366 and theta 2 is equal to sin inverse 0.3366 and it is would be 19.67 degree. Now similarly for third plane, which is for 2 to 0 and sin theta 3 0.68 and 2 to 0 is under root 22448 and this is the 4.8 and after solve we will get 0.476 and theta 3 is equal to sin inverse 0.476 and that would be 28.43 degree. And in similar way, if we solve for theta 4, that would be 33.94 degree. This is the first for Bragg's angle at which reflection will occur. There are some more angles. Now move on to the next question. From the following data, calculate the wavelength of the neutron beam and its speed. So here we have to calculate the wavelength of the neutron beam and its speed when we have the reflection spacing between successive 100 plane is 3.84 angstrom. So D100 is 3.84 angstrom. And we know for okay. And glancing angle is 30 degree and order of the Bragg's reflection is 1. So n is equal to 1 by Bragg's law. 2d sin theta is equal to n lambda. Here value of d is given is 3.84, n is 1 and the theta is 30 and we have to calculate the wavelength of neutron beam. So value of d is 3.84 and value of sin 30 is equal to 1 into lambda and lambda is equal to 2 into 3.84 and sin 30 is 1 over 2 cancel and lambda is equal to 3.84 angstrom. So the first part is So now we have to calculate the also the its speed, and we know this is a neutron, so it has a mass also, and the mass of the neutron is 1.67 into 10 or minus 27 kg, and we have to calculate its speed, and we know this is the neutron, so there should be an de Broglie wavelength, and we know the wavelength of this neutron. So in similar way, we can calculate the value of V by de Broglie wavelength relation. De Broglie wavelength is given by lambda is equal to h over T or h over mv, and V is equal to h over m lambda, and value of h is 6.02 into 10 to the power minus 34 joule second, and value of m is 1.67 into, and value of lambda is as we calculate in the first part is 3.84. When we calculate this, we will get 1.03 into 10 to the power 20, sorry, 1.033 into, and sorry, here wavelength in angstrom, so it would be 3.84 into 10 to the power minus 10. We have to take all the value in mks, because value of h is also in mks, and the value of m is also in mks, and so there should be lambda is also in mks, so should be 10 to the power 3 meter per second, or I can say 1.03 kilometer per second, value of V. So here we solved all the two parts of this question. The first one is the wavelength of the neutron beam, and the second one is the its speed. So V speed of this neutron beam is the 1.03 kilometer per second, and also the wavelength of the neutron beam is 3.84 angstrom. Now let us move to the next question. A beam of the X-ray incident on a sodium chloride crystal having a 2.81 angstrom. The first order reflection is observed at the glancing angle 8 degree 35 minutes. What is the wavelength of the X-rays? At what angle should be the second order X reflection occur? So A is 2.81 angstrom, and the glancing angle is 8 degree 35 minutes. This is for the sodium chloride structure, and sodium chloride structure is a FCC. Here I don't know about the from which plane reflection is occurred. So in this case, we will take the first reflection which would be occur in this crystal type of crystal. So we know for FCC crystal 111 plane 111 reflection occur firstly, after that 200, and after that 220, and then 113 reflection are occur, as we saw also in last question. So we will take value d11, and it should be d over under root 1 square plus 1 square plus 1 square, and the value of A is 2.81 over root 3 angstrom. So it is a d11. Now by Bragg's law, 2d sine theta is equal to n lambda, and here this is the first order reflection, so value of n is equal to 1, and 2d again is 2.81 over root 3 into Sine theta is 8 degree, 35 minutes, and n is 1, and we have to calculate the value of lambda. So value of lambda would be 0.484 as we solve this. So lambda is calculated. Now in the second part, we have to calculate the second order reflection. At what angle should be the second order reflection occur? So 2d sine theta 2 is equal to 2 lambda. So sine theta 2 value of lambda is 0.484, and our value of it is 2, and the d is 2.81 over root 3 to cancel, and when we solve it, we'll get 0.29 0.2983. This is the value of sine theta 2, and theta 2 is equal to sine inverse 0.2983, and that would be 17.38 degree. So this is all the two part of this question. First one is we have to calculate the wavelength of the X-ray, and the second one we have to calculate the what angle should be the second order reflection will occur. So second order reflection will occur 17.38 degree, and the wavelength of the X-ray diffraction is 0.484 angstrom. Now let us move to the next question. A device shearer pattern obtained from a FCC crystal with a 3.61 angstrom. Here with A is equal to 3.61 angstrom, and X-ray is the wavelength equal to wavelength of X-ray is 1.54 angstrom. Determine the Miller indices of the plane with the lowest and the highest Bragg's angle in this pattern. So I have to calculate at what angle the lowest and the at would be the lowest angle at which the Bragg's reflection will occur, and the highest Bragg angle which would be occur this condition. Now by Bragg's law, two D HKL sin theta equal to n lambda. For the first order reflection, we will take lambda is equal to 1. Sorry, n is equal to 1. And DHKL is given by A over root of H square plus K square plus L square. Here we know the value of A and the value of lambda. So value of H square plus L square would be 4A square over lambda square sin square theta. And we know the maximum value of sine would be +1 and the lowest value of sine would be -1. So in all cases, sine square theta would be maximum 1. So H square plus K square plus L square should be smaller than or equal to 4A square over lambda square, or value of A is 3.61 square and lambda is a 1.54. So when we will calculate it, we will get H square plus K square plus L square should be smaller than or equal to 21.97. So here we have to check at which combination h square plus k square plus l square is smaller than or equal to 21.97. But in this question, there is a fact. This is a FCC crystal. So we have to take care about the which reflection for value of HKL are occurred or no. So now again by selection rule, for FCC, HKL all are given or all are odd, as we also see in the last question, and the combinations are going in such a way 111. There is the, the Miller indices of lane. If I see the family of planes, so the family of plane 1111, second would be 200, third would be 220, and after that 113, after that 113 and 222. If I check the total for h square plus k square plus l square, for this h square plus k square is 3, for this 4, for this 8, for this 11, and for this 2 2s of 12. And now check the more. After that, there should be the families 4 to 0. If I see, or before this, there should be 1 3 3, and after that there would be 4 2 2, and after that 3 3 3. And if I see the total of h square plus k square plus l square for this, and 3 3s are 9 and 8 17, and for this 4 16 and 4 20, and for this 4 16 and 8 24, and for this 27. This is the value of h square plus k square plus l square. So let us see. There should be h condition which I got. The reflection will occur when h square plus k square plus l square smaller than or equal to 21.97. So here we can see lowest reflection which pair can occur is 111, and the highest should be smaller than 21.97. Before just 21.97 is 20. It means 4 to 0. So 1 family and the 4 to 0 family, from which we will get the highest and the lowest drag angle. So for this, I will get lowest Bragg's angle, and from it I will get highest Bragg's angle. This is the manner how we will got the value of Bragg's angle. In this session, I cover all the type of question which is are asked in the any competition exam like NET, NAT, GATE, or anything this level. I hope you learned from this session. Thank you so much. for listening me. If you have any query or any doubt, you can also ask that in comment section. Thank you. Thank you so much.